Hello everybody, this is going to be a quick demo where we show off building our first KMerCounter. So in this case, we're going to build the StringHashMapKMerCounter. It's part of the warm-ups. And after you've constructed one of these things or someone's constructed it, they will call parse on a list of subsequences. And if you watch the video where we used a KMerCounter, you'll know why we split them up. There's sort of errors in the reads that we that produce some bad data or unknown reads. So we sort of split it up into the useful sections, and now we're being asked to count it. We're told the data or the chromosome data we're supposed to count, and then what K is. So let's just dig in and start to, one of the first things I like to do is if I have to process a whole bunch of data, sometimes it's nice to just start to do that. Like let's touch all the data first, right? So like for sequence and sequences, right? I'm going to have to count all these guys, so let's do that. And then I'm going to have to go through all of the data. Now, you will have built one of these before. If I go to string, if I go to star Kmer, star mapper, back in the Kmer counting, we had a KMerCounter map counter over here in MapReduce Apps Kmer Studio back when we were doing int count. And there was a part where you've sort of built a KMerCounter before in the MapReduce section. Had this function that I put right in here for a two-string Kmer for you. We're going to call one in Kmer utilities now. But that's kind of the same process we're going to do for each one of these sequences. So let's just, let me sort of build this slightly wrong to start. So for offset equals 0, offset less than sequence length plus offset. This is going to march sort of the starting point of the Kmer one at a time through our sequence of data, and let's convert it to a string Kmer. Okay, and as I was mentioning, there's Kmer utilities that has a whole bunch of useful methods. Let's sort of do this two-string thing. And it's asking for a byte array. And a lot of times what people do is they'll like complete to the first one and then throw this in. So if everyone wants to pause, sort of figure out what's wrong with this, we'll come back. Okay, so hopefully sort of at least a few of you have realized that like, all right, so now I'm marching through, I'm supposed to be making strings of length K here, and I've just taken the entire sequence and built it into a Kmer. That is what this guy does. It takes some byte array, in this case, the entire thing, and converts it to a string. And that's not what I want. I want just a subset of it. So there's a second one up here that takes like two string that takes a sequence and an offset and some K, which is exactly what we want. So let's pass in offset and K here. Now, so now we're like at least making something that's K long. So at this point, we will have gone through and made a bunch of Kmers. What is wrong with this? I'm going to return null here just for now so that it will compile and run. Now I want everyone to pause and sort of figure out what has gone wrong. All right, and so let's try to run this thing and see what happens. So this is gonna run the test, and like we come up here to SARS-CoV-2 and we get a string out of bounds exception. It was told to, the first place where it failed is when offset was 22 and the count was 5. So we're counting the 5 mers obviously. And the length is only 26. So what we're doing here is we're like counting off the end, right? So like for every single one, independent of K, we're going off the end. And so what I'm going to say is we've talked about this in class before, and now we are no longer in class, but like we'll talk about it again. How many, ask yourself, so how many Kmers are there if I ask for the 100 mers and 100 long sequence? How many are there if there's, how many 1 mers are there in a 100 long sequence, right? And if you answer those questions, what you'll arrive at is that the number of Kmers in a thing is the length minus K plus 1, okay? And so I'll leave it to all of you to check to see that that is in fact the right answer. And you can test yourself with 100, 99, stuff like that. So now, we're back to sort of throwing this null pointing exception. That is when I'm getting the count back, right? So that's because I'm not actually returning anything, but at least I'm no longer throwing this exception up here. So I'm actually processing, going through all the data, and at least not throwing an exception. So now I have this k-mer. I know where it is, and I want to do is sort of keep track of this. So just like before when we were counting and putting a map, this is the string hash map counter. So this is a massive clue. We're going to make a map. And it's going to go from string to integer. And just like word count, k-mer count from before, all these other things, we're going to count the times that we find this. So let's call this the map, and that's going to be a new hash map. It says string to integer. I kind of prefer to take it out and let it infer it for me. And now I can say, well, all right, so integer previous count equals the map.get that k-mer. So I'm going to look up the previous value for that. If prev does not equal null, this is a sort of an old C program where I check everything positively and choose not equal to null as the positive form. If the previous value is null, right, is not null, then my next value, so I'm going to do this as a lowercase int, the next value, next equals prev plus 1, else next equals 1. Now I'm going to go and take my map and call put on it. Now there's compute completing to it, which I like. We're going to do compute in a minute, but for right now we're doing a simple sequential program, and we'll talk about why compute is a good idea in a second. The key is the k-mer, because that's what we're trying to count, and the value is now next. Okay. Now I have this map that is completely filled when I'm done it, which will kept track of all the k-mers in here, and I just need to build one of these k-mer count interfaces. So if I tunnel into this, I can hit F4, and it gives me a list of all the things that implement this interface. You can see it's an iterable that gives you which k-mers it found and get count. If I look in here, I've got one that's got a map one, that obviously takes a map of some type. Oh, look here, there's one called StringHashMapKMerCounter. It's almost as if someone's built everything that we need, right? And I encourage you all to look into this if you're interested, but largely what we need to do is return a new one of these that will wrap the map and k, if that's the right order. It might be the other way. Let me see what it's asking for. Yeah, it's k and then the string. So k, excuse me, then the map. And the idea is that we just need someone who's going to wrap this map that we built that has all the information and adapt it into this k-mer count. So now if I run this test, excuse me, I run the unit test. So let me run the warm-up test. Hopefully we will pass all of this string hash map tests. And now we're failing the concurrent hash map test. So we'll make that the subject of another video in a second.